Two. My name is Muhammad Shazam Musaimi. Today we want to talk about control. Okay, control chart is a source of variation in production and service processes. The common causes of variation is because random causes that we cannot identify, unavoidable cause like difference in process variables like diameter, weight, service time, temperature, and etc. Assignable causes of variation. It is because can be identified and eliminated. Second, typical causes are poor employee training, worn tool, machine needing repair. Measuring variation, the standard deviation. Okay, this is a graph for small vs large variation. For the purple graph, it is small standard deviation, and the red, large standard deviation. And the center of the graph is the mean. Okay, process capability. Process capability is a measure of the ability of a process to meet preset design specification. It is to determine whether the process can do what we are asking it to do. Uh, Design specification must have tolerance. Is to determine by design engineers to define the acceptable range of individual product characteristic. For example, physical dimensions, elapsed time, and other on. Second, based upon customer expectation and how the product works, not that. Okay, these are the example of relationship between process variability and specification width. Okay, for the A is the process variability meets specification width. Second, outside specification width, and the C is within specification width. So it means the A, it meets the specification, so it can be accepted. But the B outside specification, so it is upper the LSL and USL. Okay. Process control charts. Control charts show sample data plotted on a graph with center line CL, upper control limit UCL, and lower control limit. Okay, this is the example of process control chart. They have the plotted rate plotted observation out of control. Okay, this is the graph of setting control limit.
Okay, they have a few type of control chart. First, control chart of variable that are used to monitor characteristic that can be measured, for instance, length, weight, diameter, time, and etc. Second, control chart for attribute are used to monitor characteristic that have discrete value and can be counted. Example, defective, number of flaw in a shirt, number of broken egg in a box, and etc. They have control chart for variable. First is mean, known as X bar chart. Track the central tendency, the average value observed over time. Second is range, R chart. Track the spread of distribution over time. Estimate the observed variation. X bar and R chart monitor different parameters. As you can see from the picture, this is the example of shift in mean detected by X chart but not by R chart. For the B picture, shift in dispersion detected or detect in R chart but now by X chart. Constructing a bar chart. This is one of example. A quality control inspector at the Cocoa Fizz soft drink company has taken 3 samples with 4 observations. Each of the volume of bottle filled. If the standard deviation of the bottling operation is 2 ounces, use the data below to develop control chart with limits of 3 standard deviation for the 60 ounce bottling operation. This is a timetable for time 1, time 2, and time 3. Observation, they have 4 observations, 1, 2, 3, and 4. They have few steps. So for step 1, we need to calculate the mean of each sample. To calculate the each sample, we need to calculate observation 1 and time 1. Step 2, calculate the standard deviation of the sample mean by using this formula. Step 3, we need to calculate CL, UCL, and LCL. Step 4, we need to draw the chart based on the calculation. An alternative method for the X bar chart using R bar and the A2 factor. Use the method when the sigma for the process distribution is not known. Use factor A2 from the table 6.1. This is an example. Sample size, factor for X chart, factor for R chart. Step 1. Calculate the range of each sample and average range. This is the called as an example. We want to find the range 0.2 plus 0.3 plus 0.2 and divide by 3. Step 2. Calculate CL, UCL, and RCL. Control chart for range chart, R chart, centerline control limit calculation.
Okay, this is the R bar control chart. As you can see, there's a ounce versus sample mean. So the blue line is the sample mean and the dotted line is UCL and the line straight line is CL. So the result is there's ups and downs. Next, control charts for attributes, P charts and C charts. P charts quality and characteristics that are discrete and involve yes or no or good or bad decisions, such as percent of leaking caulking tubes in a box of 48, percent of broken eggs in a carton. Also, use C charts for discrete defects when there can be more than one defect per unit. Number of flaws of stain in a carpet sample cut from a production run. Number of complaints per customer at a hotel. Okay, constructing a P chart. As you can see the description or the question, you can see the sample size, and the number of defectives as shown below. Okay, step 1. Calculate the percent defective of each sample and the overall percent defective P bar. As you can see on the table. Next. And the step 2. Calculate the standard deviation of P. The formula were given um, and put all the necessary value in the step 3. Calculate the CL, UCL, and LCL. The centerline P bar. CL equal to P on equal to 0.09 control limit for 3 sigma limits UCL and LCL as shown below. Step 4. Draw the chart based on the calculation.
Okay, the next step is we should construct a C chart. As you can see, this is an example of the big against number of complaints. This is a formula to calculate CL, UCL, and SL. As you can see, CL is complaints over sample is 22 over 10 equals to 2. And then to calculate UCL, you have to use C bar plus Z cert C bar. So 2.2 plus 3 cert 2.2 equal to 6.65, and also LCL uh, C bar minus cert C